let's continue with completing the square. So here's another problem. So let's say we want to complete the square and solve x squared plus, let's not do plus, let's do another minus. Minus 5x plus 11 equals 0. Okay, so the first thing that we want to do to complete the square, let's isolate all the x's with and the numbers. So we'll move the 11 over. So I have x squared minus 5x is equal to negative 11. Okay, now let's identify our b term. Our b term is going to be this negative 5. Negative 5 divided by 2 and then square it. This is going to give me a positive 25 over 4. Okay, so this 25 over 4, I'm going to add it to both sides of the equation. Okay, so I'm going to get x squared minus 5x and then a negative 11 on the other side. And then here, I'm going to just add this 25 over 4 and add this 25 over 4. Okay, so when I factor this out, this is going to be x minus whatever this is on the inside. And then the inside here is going to be minus 5 over 2. Okay. Now, on the other side, I can either use my calculator or you can just find the least common denominator. And this is just going to give me negative 19 over 4. Okay. So now the last thing that I'm going to do is take the square root to both sides. And when I take the square root, I also add plus or minus. So you're going to get x minus 5 halves is equal to plus or minus. The square root of a negative is just going to be an I. The square root of 19 is going to stay as the square root of 19. The square root of 4 is going to be 2. Okay, and then I'm just going to add 5 halves to the other side. So you're going to get x is equal to 5 halves plus or minus I square root of 19 divided by 2. So this is my solution. You can write it as x equals 5 halves plus I square root of 19 over 2, comma 5 halves minus I square root of 19 over 2. Okay, this probably will be a web assign problem like this. You have to write it like that. Okay, so that's what completing the square is. Now, the only problem is that we've just been doing problems where there's nothing in front of the x squared. It's just a 1. So what about if you don't have something like that? So how do we solve it? So I'm going to write it, how to solve when you have ax squared plus bx plus c equals 0 and you have a number there. So how do you solve it then? Well, one of the first things that you want to do is first isolate x's on one side and numbers on the other. Okay, that's still what you want to do. The second thing that you want to do is factor out the a term from the x's. So all the x's that I have on one side, I'm going to factor out that a term, whatever a is. Okay. Identify b. And find b over 2 squared. Add b over 2 squared on the left-hand side. And on the right-hand side, add b over 2 squared times a. You'll see why. Okay. Then factor and solve. Okay. So that's basically what it is. So you can take a little bit of time so that you can do it. Okay. Now let's do a problem. Okay, and you'll see why we're multiplying it by this a, and that's the only thing that's a little bit subtle. So let's do an example where we want to solve it by completing the square. So let's take 3x squared plus 30x minus 27 is equal to 6. So we want to solve by completing the square. Okay, so the first thing that you want to do is isolate the x's from the number. So let me add the 27 over. Okay, so I'm going to take this 27 and add it to 6, and I'm going to get 33 over here. And over here, I'm going to have a 3x squared plus 30x. Okay, now this is not going to be my b because I still have this 3 in front of it. So what the directions say is that now I'm going to factor out the a term. Okay, so I'm going to factor out this a, and in this case the a term is a number in front of the x squared, which is going to be this 3. So I'm going to factor out this 3. Okay, so what am I going to get? So I'm going to take out this 3. I'm going to have x squared plus 10x, and over here it's just going to be still the 33. Nothing really happened to it. Okay, so now that I have my factored form, I kind of have what I want. Here's my b term, this 10. I'm going to take this 10. I'm going to take the 10, divide it by 2, and then square it. Okay, so this is going to give me 5 squared, which in turn gives me 25. Okay, so now let's do this problem really carefully. So I'm going to have 3x squared plus 10x equals 33. Okay, so it says here on the right hand side, on the left hand side, I'm going to add this b squared over 2, and the b squared over 2 is this 25. So I'm going to add this 25 here. Now here I'm not going to add a 25 because I didn't just add a 25 on this side. Notice this 25 is being multiplied by this 3. So when I redistributed, I didn't add a 25. I added a 25 times this 3. So the thing that I'm going to add over here is going to be the 25 times the 3. So whenever you add something here, you always have to multiply it by whatever's there. Okay? So let's finish this up. So you're going to have 3. This is now going to be a perfect square, x plus 5 whole quantity squared. Okay, notice that the middle term was just here. And then you're going to take 33, add it to 25 times 3, and that's going to give me 108. Okay. Okay, now all I got to do is just solve for this problem. I'm going to divide by this 3 because I got to isolate the squared term. I have x plus 5 whole quantity squared is equal to 108 divided by 3, which gives me 36. Now I'm going to apply a square root to both sides and also add plus or minus. So I have x plus 5 is equal to plus or minus 6. Then I'm going to subtract this 5 finally. Get x is equal to negative 5 plus or minus 6. Okay, so it's going to be negative 5 plus 6, and negative 5 minus 6. This is going to give me a positive 1. This is going to give me a negative 11. Okay, and that's all there is. Okay, so it is a little bit of a lengthy process, and you do have to come up or think for a couple of things, especially when you pull out a 3, right, or you pull out something from the very beginning. Okay, so let's just do one more problem. And then just to finish it up, okay, so let's say we had 5x squared plus 20x equals 15. Okay, so first things first, everything is already broken up between numbers and x's. I'm going to take out a 5. And in the inside, I'm going to have an x squared plus 10x equals 15. Okay. I didn't like this. Okay, whatever. We'll continue doing it. Okay, so now we're going to take this 10. It turns out to be the same thing. So, oh, wait a minute. That's wrong. This should be a 4. Because you got a 5. Okay, I like it now. All right, so now I'm going to take this 4. I'm going to divide it by 2 and then square it. So this is going to give me 2 squared, which gives me 4. Okay, so what I'm going to do is I'm going to take this 5, x squared plus 4x, and then here I'm going to add a 4, divided of 15. So here I'm going to add a 4. Now here I'm not going to add a 4 because it's going to be 4 times whatever 5 is. So it's going to be a 4 times 5. Okay, so I'm going to have 5. This is a perfect square now, so it's x plus 2 squared, because there's a 2 there. And then this thing is going to be 15 plus 20. That's going to give me 35. Okay, going to divide both sides by 5. I'm going to get x plus 2 whole quantity squared equals 7. Then I'm just going to take the square root to both sides, plus or minus. X plus 2 equals plus or minus square root of 7. And I'm going to subtract it by 2. So x is equal to negative 2 plus or minus square root of 7. Okay, and that's it. Okay, now these problems can get really, really complicated. For example, I could have done 5x squared minus 3x equals negative 10. And then you can see that I can take out a 5. And this is actually going to get really ugly really quick. So you see something that looks like this. So you can still do it. You can still divide by 2 because this is going to be my b term. You can still take negative 3/5 divided by 2 and then square it. If you do arrive at this type of problem, one of the good things that I always think about is that if all I do is just I multiply these two, right? Because this is just negative 3 over 10 because it's being divided. So basically this 5 is already on the bottom. Now I'm bringing this 2 on the bottom, so it's going to be 5 times 2, which gives me 10 squared. Okay, so then you'll get 9 over 100. So you will add 9 over 100 here, and you will add 9 over 100 times 5. So problems like these get really, really gross. Something like this won't be on the exam. I'm not sure if it's on the homework, but for the exam, if I give a completing the square, it will be something as straightforward as these other previous problems. So this is as ugly as it's going to get. Okay, but I don't think I will really test you much on this. Okay.